Okay, now that we know what logs are, let's look at some ways to use them. Let's look at some of their rules and some ways we can solve equations. So last time we were looking at 2 to the power x is equal to 56. And we know x is between 5 and 6, right? Because 2 to the power 5 is equal to 32, and 2 to the power 6 is equal to 64. And this is 56. So 56 is between 32 and 64. So we assume x is between 5 and 6, but we don't know how to get there yet. Let's say we had another equation. We had 5 to the power x is equal to 32, let's say. Well, we know 5 squared is 25, and 5 cubed is 125. 32 is between 25 and 125, so x is between 2 and 3. It will probably be closer to 2, right? Because 32 is closer to 25 than it is to 125. But we don't know how to solve it yet. We will learn soon. So let's look at some basic rules first. So let's say you have ln. Okay, ln means base e, remember? Ln means log base e. We're going to use ln now from now on instead of log because ln is more common. So if you have ln a plus ln b, this is the same as the natural log of a times b together. So let's say I had ln 5 plus ln 6. You put in your calculator, that's the same as ln of 30. That's the first rule. And similarly, ln a minus ln b is equal to ln, and I guess you could assume, you could guess this from now, would be ln a divided by b. So if you had ln 10 minus ln 5, that's the same as ln 10 divided by 5, which would be ln 2. So those two are the very simple ones. Now, a bit more interesting. So let's say we had ln of a to the power b. That is equal to actually b times the natural log of a. So you're multiplying the natural log of a by b. So let's say I had ln of 5 cubed. So that's ln of 125, right? But that is also the same as 3 times ln 5. You can put this in your calculator and you will see these are all correct. Now an interesting one. So similarly from here, let's say you had ln a to the power minus 1, right? B is just minus 1 in this case. Well, that is equal to ln of 1 over a, right? But then a to the power minus 1 is the same as minus 1 times the ln of a. So that means ln of 1 over a is equal to negative ln of a. So if I told you ln 2 or ln a half is equal to ln of 2 to the power minus 1, which is equal to negative ln 2. Again, put these in your calculator and you will see these are all correct. And now an interesting one. So before we get there, let's just do this first. Of course, ln of e is equal to 1, right? Because you're saying basically e to the power of something is equal to e. E to the power of 1 is equal to e. So in general, the log of, let's say, x, and then you have x here, is equal to 1. Because of course, x to the power 1 is equal to x. So that should be obvious, but if it wasn't, then ln of e is equal to 1 is important. Now, what if we have e to the power of ln x? What is that equal to? Well, let's let it equal to something like L. Let's just call it L, okay? Let's call ln x, let's call it k, okay? So that means e to the power k is equal to x. Okay, so far so good. And if ln x is equal to k, that means we have e to the power of k is equal to L. Okay, this is just because we let ln x equal k, so instead of ln x over here we have k. So e to the power k is equal to L. And then from here we have e to the power k is equal to x. This is just using logs. Now let's take the ln on both sides. So we have k, we have ln, let's write that again. We have ln of e to the k is equal to ln of x. But remember, ln a to the power b is equal to b times ln a. We saw that right here. That means we can bring the k in front. So we would have k times ln e is equal to ln x. Well, what's ln of e? That's just 1, right? We saw that ln of e is equal to 1 right here. That means k is equal to ln x. Okay, now what do we do from here? So we have e to the power k is equal to L, e to the power ln x is equal to L. K is equal to ln x. Take the natural log of these things on both sides. So we would have ln of e to the power k is equal to ln of L. Now let's bring the k back outside again. So we have k times the ln of e is equal to ln of L. Right? So far we haven't done anything different. Again, ln of e is just equal to 1. So we have k is equal to ln of L. But k is also equal to the natural log of x. So that means the natural log of x is equal to the natural log of L. Now, of course, if we are applying natural log on both sides, we can just undo it, right? So we would have x is equal to L. But L is equal to this. So that means that e to the natural log of x, which is equal to L, which is also equal to, well, x right here. And that's it. That's the derivation of it. If you want, this is like very long-winded, but usually if you have e to the power of the natural log of something, then that something is what it's equal to. So let's solve this equation, this question that we had right here. 2 to the power x equals 56. Let me write it again. So we have 2 to the power x equals 56, and now we know how to solve this equation. Let's take the natural log on both sides. So we have ln of 2 to the power x is equal to ln of 56. Well, this is ln a to the power b, so we can bring the b outside. So we would have x times the natural log of 2 is equal to the natural log of 56. And now we just divide by natural log of 2 on both sides. So we have x is equal to the natural log of 56 divided by the natural log of 2. And this is approximately equal to, I did it somewhere. This is approximately equal to 5.81. So, of course, I guess was correct. It's between 5 and 6. And it makes sense that it's closer to 6 than 5, right? Because 56 is closer to 64 than it is to 32. Now let's do 5 to the power x equals 32. So we have 5 to the power x equals 32. So take the natural log on both sides. So we have natural log of 5 to the power x is equal to the natural log of 32. And then again, you can bring the x in front, right? So we have x times the natural log of 5 is equal to the natural log of 32. And then x is equal to the natural log of 32 divided by the natural log of 5, which is equal to, I did it once again, and that's 2.15. And that makes sense because 32 is way closer to 25 than it is to 125. So 2.15 makes sense. So that means 5 to the power of 2.15 is equal to 32. 2 to the power of 5.81 is equal to 56. Now let's do an example question that's more difficult and it will make more sense. So we have solved the equation ln brackets e to the 2x plus 3 is equal to 2x plus ln 3, giving your answer correct in 3 decimal places. Okay, let's bring ln 3 to the other side first. So we have ln of e to the 2x plus 3 minus ln 3 is equal to 2x. Okay, remember ln a minus ln b is equal to ln a divided by b. So this is the same as the natural log of e to the power 2x plus 3 divided by 3. And that is equal to 2x. Okay, so far so good. Now let's raise everything e to the power of everything on this. So if we have e to the power of the natural log of this, well, remember when we said e to the power of ln x is just equal to x, right? So the e to the power of ln of anything is equal to that something. So this is actually equal to e to the power 2x plus 3 divided by 3. And again, we raise this side e to the power of that, so that's e to the power of 2x. So all we've done is we have done e to the power of the right hand side and the left hand side. So on the right hand side we have e to the power 2x. On the left hand side we have e to the power ln e to the 2x plus 3 divided by 3, which is just the thing inside the brackets, which is e to the 2x plus 3 divided by 3. Okay, now we can multiply on 3 on both sides. So we have e to the power 2x plus 3 is equal to 3 times e to the power 2x. Then we can bring this e to the 2x on the other side. So we have 3 is equal to 3 e to the 2x minus e to the 2x. So now we have 3 is equal to 2 times e to the power 2x, right? Because 3 minus 1 is 2, 2 e to the power 2x. Divide by 2 on both sides, so we have 3 divided by 2 is equal to e to the power 2x. And then from now it's very simple. We take the natural log on both sides again. So we have the natural log of 3 over 2 is equal to 2x times the natural log of e. But again, this is just equal to 1, right? So we can get rid of it. So we have 2x is equal to ln 3 over 2. And now it's simple. X is equal to 1/2 times ln of 3 over 2, which is approximately equal to 0.2027, and so on and so forth. But I think we need 3 decimal places. Yep. So that is equal to 0.203. Correct to 3 decimal places. And yeah, that's our answer for x. So that means e to the power 2 times 0.203 plus 3, the natural log of that is equal to 2 times 0.203 plus the natural log of 3. And we only have to use these very basic rules. You should probably take a picture of these rules or write them on your own, and it will make sense to you. But yeah, this is rule number 1. This is rule number 2. This is rule number 3. And then from rule number 3, this is rule number 4, because these are related. And then this is number 5. And then from 5, we have 6, which is also related to 5. So I'll just draw a line right here. This is rule number 6. So yeah, I hope you enjoyed that video. If you did, please like, share, subscribe, and comment, and let me know what else you want to see in future videos.